Hey guys, so today we will be graphing cubic functions. So yesterday we did radical functions, and today we're just going to be doing cubics, which means that our highest degree is a 3. So a cubic function in standard form is ax cubed plus bx squared plus cx plus d. So we see there that the highest degree is 3, so that's where we get the cubic from. And then a, b, c, and d are just numbers, and the only one that can't be a 0 is a, so the first one. And so when we are graphing the parent function, we've got this half of a table done for us, and we're going to complete it and then graph it out. So I like to start with 0, so 0 cubed is still 0. Negative 2 cubed would be negative 2 times itself 3 times. So negative 2 times negative 2 times negative 2. Which gives me positive 4 times negative 2. So we see that this would give me the positive 4. And so negative 2 cubed is negative 8. So a negative number cubed will give me a negative number. Negative 1 cubed would be negative 1 times negative 1 times negative 1, which results in a negative 1. Then 1 cubed would be 1 times itself 3 times, which is 1. So it'd be 1 times 1 times 1. And then 2 cubed is 2 times 2 times 2, which is 8. So we start at 0, 0. I'll do the positives first. So 1 goes to 1, and 2 goes up to 8. Then the negatives, we have negative 1 goes to negative 1, and negative 2 goes to negative 8. So then when we are filling out this graph, we'll connect these points and make a curve down the middle. So this is what our parent function looks like, and just like yesterday, this is where all of our functions are going to stem from. So we'll make our transformations based on this parent function and this table that we have here of the points. So the domain of the parent function, my x values are all real numbers, because it's going to go infinitely to the left and infinitely to the right. And that's the same thing for my y values. And behavior, as x approaches infinity, f of x or y approaches. So if I'm going to the right, f of x is increasing, so f of x is approaching infinity. Or we would say increasing. As x approaches negative infinity, so going to the left direction, my y values are decreasing. So we are approaching negative infinity. My zeros are wherever it crosses the x-axis, and the only point where it is crossing is 0, 0. Where are the values of the function positive? So the values of the function mean my y values. So where are my y values positive? And that is between 0 and infinity. Where are they negative? Between negative infinity and 0. Actually, we're going to make that a parenthesis on the 0 because 0 is neither positive nor negative. Where is the function increasing? So the function is increasing wherever the y values are increasing. So that is the same as where is the function positive in this case. So from 0 to infinity, and it is decreasing from negative infinity all the way up to 0. Is the function even, odd, or neither? So we know that the function is odd because the degree is odd, and that means that f of negative x would be the same thing as taking negative of f of x. And that's just the formal definition of even and odd. So on the examples, I'm going to do 2 of them with y'all, and then the rest of them will be for your homework. So we are describing how they are related to the parent function, and then we're graphing. So essentially what we're doing is listing the transformations and then graphing. So just like our transformations on a quadratic or on a radical function, what goes on inside is the opposite, and what goes on the outside is as is. So plus 4 means we're taking those points and having a horizontal shift to the left. Four units. And then that minus 6 means we're having a vertical shift down, because we take it as is, 6 units. So we're going to graph our parent function, and then we will translate those points left and down. So we're going to take each of these points and move it to the left 4 units. So let's start with the lowest one here. So we're going to go left to right just so we don't get confused on the points. We'll go left, 1, 2, 3, 4, and down 6. It'll be off the graph. So we'll go left 4 and down 6. So right here. We'll go left 1, 2, 3, 4, and down 6. And then that last point, 2, 8, we'll go left 4 and down 6. So then we'll connect those with the same curve that the parent function has. So it's like we picked up the graph and moved it left 4 and down 6. So then we have the graph of the new function there. On number 5, you see that I moved the 1/3 from the inside of the parentheses to the outside. So just make sure that you do that on yours as well. Then on number 8, we have 2 times x cubed plus 4. So whenever you have a value greater than 1, whenever you have a vertical stretch or shrink, if you have a fraction, whatever's in the front, if you're going to be multiplying by something, it's a little difficult to imagine what the stretch or shrink will look like on the graph. So what I like to do is make my table of values, and I'm going to teach each of the original points. So I've got -2, -8, oh, just the x values, sorry, -2, -1, 0, 1, and 2. And I'm going to apply this new function to them. So I'm going to plug these x values in and see what my new y values would be. So y equals 2 times x cubed plus 4. So you can put that in your calculator. You would have 2 times -8 plus 4, which is -16, plus 4, which is -12. We'll do the same thing with the next point. We have 2 times -1 cubed plus 4. So we would have -1 times 2, which is -2, and plus 4 is +2. We would have 2 times 0 cubed plus 4, which would be 0 plus 4, which is just 4. And 2 times 1 cubed plus 4, which would be 2 plus 4, it gives me 6. And 2 times 2 cubed plus 4. 2 cubed is 8, so 2 times 8 is 16, plus 4 is 20. So then these are my new y values. So each of these points, I'll take -2 and go to -12, which is off my graph. I'll go to -1 and go up to 2. Then I'll go to 0 to 4, from 1 up to 6, and 2 will be all the way up at 20, so that's going to be a very steep line there. And we saw that -2 would be at -12, so that's a pretty steep line there as well. So that's what our stretch looks like, and we also took our graph and moved it up 2 units from where it was. So then for the remaining problems, those will be your homework, which only leaves you with 9 problems. So you've got 9 problems to do with our cubic functions. You're going to list out what the transformations are. It does help to sketch out the parent function first and then move your points based on that. And it is just like yesterday's work, but with a different parent function. So make sure that you turn this in on Canvas whenever it is complete.